Hi, in this video, I'm going to talk about different sort of operations we can do with our tensors and look a little bit about what happens with them. And I'm just going to think about the most basic operations of multiplying these objects together in different ways and adding them together and talk a little bit about the rules and the way the indices are going to work when we do these different operations. So we've already written down some tensor products. So let's start there. And here I'm thinking about just multiplying two tensors together or more. So multiplying two tensors together results in a higher ranked tensor. And here I'm assuming all of our indices are unique. In a minute, I'll talk about contractions, which is when we have these repeated indices. So here I'm assuming we have unique indices. Well, so this just, what happens here if we have A mu, B nu. This acts just like an object now with two indices. So this is C, this one also can be thought of C mu nu. So if I multiply a rank 1 tensor by another rank 1 tensor, I end up with a rank 2 tensor, right? So 1 plus 1 equals 2, the rank. Or we could do something, maybe we start with a rank 2 object and we multiply it by, and now I'll do something different. I'll have a downstairs index. That doesn't matter. So we have a rank 2 object plus a rank 1 object. This is some new object, C mu nu, where we keep all of the indices in order. Upstairs, stay upstairs, downstairs, stay downstairs. So this is going to be some rank 3 tensor. So in general, what you do if you are multiplying tensors together, you just add the rank of those tensors to get the rank of the resultant object that you're sort of thinking about. So what if we have some of these indices matching? Then we have a contraction. And this can be when you're multiplying different objects together, or it could be a contraction within the same object. So this is just if two indices match in a single tensor or a tensor product, this reduces the rank. So for example, if I could just have a tensor where my two indices, I've chosen for them to be the same. So this actually is just, a scalar. So we could just write it as t without any indices because all of our indices have been contracted. So this would be rank 0, actually. Or if we have A mu B mu, this also is a scalar, which is rank 0. Or maybe we have T mu nu, A nu. Then this looks like some object. I don't know, I'll just give it some other name, C mu, which is rank 1. So only, we'll learn this terminology soon, only what are referred to as our free indices. Only our free indices contribute to the rank of our tensor. These ones that are summed over, because we've summed over them, they aren't really indices there anymore because they're just representing a sum for us. All right, so in general, if you contract a tensor, then that reduces the rank of your tensor. Okay, the third thing I want to talk about is how you can sum these things together. This does not change the rank. I'm not sure if my iPad is, oh, okay. Sorry, my iPad was being a little slow. And there are a couple rules. You can only add tensors with the same rank and matching indices. And what does this mean? Because remember, so a rank 1 object is like a 4 vector. A rank 2 tensor, you can sort of think of as like a matrix. You can't add a vector to a matrix. That's not a mathematical operation that's allowed. And so that's really what I'm saying by you have to have the same rank. So I can add 2 vectors together, or I could add 2 matrices together, but adding a vector to a matrix isn't something that we can do. And so, for example, we can add A new plus B new, and this is some new vector, C new. Or, again, these could be downstairs. Or we could have a tensor. And notice all of the matches, it's not just that the numbers match, that the indices themselves match. So some things that are not allowed are A mu plus B new. This doesn't make any sense. So this is just not something that we can do. A mu nu plus B sigma. That we can't do. That's like adding a matrix to a vector and the indices don't match. So this is bad in all sorts of ways. We can't A mu plus B mu. This doesn't make any sense where one of the indices is upstairs and the other is downstairs. So those are all things that are not going to be allowed. And as we do more examples of these things, hopefully it'll become clear. One other comment I want to make is we've been talking about how when we contract, we have a repeated index. So here we have this mu upstairs and this mu downstairs, and they're summed over. It's important to note that when we're using this Einstein summation and we talk about repeated indices, we do not mean this. Here you could also say, oh, that new index is repeated. I mean repeated within a given term. So there's no sum in this case. Again, also the sums are always, it's going to be one upstairs and one downstairs. And so this is not usually what people mean when they're talking about a repeated index. When people are talking about repeated indices, which are summed over, they're all in the same term. So that's just a subtle point that I wanted to make sure was clear. Okay, so that's some of the basic operations for dealing with our tensors, adding, multiplying, etc. Of course, I didn't talk about subtracting, but hopefully it's clear. You just add a minus sign to it, and everything I just said is still true.